Welcome to this presentation titled Dosage Calculations for Medication Administration. The purpose of this presentation is to walk you through the calculations that are required to safely administer medications. Let's start with a very basic and simple medication order and calculate how much medication we need to give this patient. The first thing that you should do is read through the question. So we see here that we have a prescriber order, and a prescriber is like a physician or a nurse practitioner, and in some cases physician's assistants can prescribe. And what the prescriber has ordered is morphine, 5 milligrams. And they want you to give that intramuscularly every 6 hours as needed for severe pain. This information here you don't need to know right away in order to calculate how much medication to prepare. So if it helps you when you're taking tests or getting ready to prepare medications, cross off the extraneous information that you don't need to know right now. What you need to know right now is that morphine, 5 milligrams, has been ordered. What you have on hand in a vial, so we're going to draw a little morphine vial here, and this is full of morphine, and what you have on hand in this vial is 3 milligrams of morphine in 1 milliliter of fluid. That's what it says here. You have morphine, 3 milligrams per 1 milliliter of fluid. So what's been ordered is 5 milligrams, and you need to give what's been ordered is 5 milligrams, and that's what you need to give. But what you have available in this vial over here is 3 milligrams per mil. So now the question asks you how much medication should be prepared. And the question asks you to mark the amount to be administered on this syringe over here and write your answer down here in the space provided. All right, so let's take a look at what we have. The next thing you want to do is take a look at the unit dose. What's been ordered is milligrams, and what you have on hand is milligrams. So right away you know that you don't have to do any conversions. Some medications will be ordered in grams, but all you have available is milligrams. So in that situation you have to do a conversion first, but since both of your units are in milligrams, no conversion is needed. I'm first going to show you one method, the ratio method, to determining how you go about calculating this dosage. What I like to do is put over on the left-hand side what I have on hand. Whoop, there we go. That A does not want to have a thing. So what I have on hand is 3 milligrams in 1 milliliter. And then on the right side of the equation, you write down what you need. What is needed, okay? And what is needed is 5 milligrams, but we don't know how many milliliters that is. So the next thing that you want to do in this type of equation is to make sure that your unit doses are in the same place. Milligrams are in the first place on this side of the equation. Milligrams are in first place on that side of the equation. Milliliters are in second place on this side of the equation. Milliliters are in second place on that side of the equation. The next step in this process is to multiply the two outer numbers. 3 milligrams times x equals 3x. Then you multiply the two inner numbers. 1 milliliter times 5 milligrams is 5. So you set up the two outer numbers on the left-hand side of the equation and multiply the two inner numbers and put that on the right-hand side of the equation. Now, using algebraic processes, you want to isolate the x. So in order to isolate the x, you have to divide this side by 3, and that means you also divide that side by 3. This crosses out. Now you have x equals what? Well, if you divide 5 by 3, you get 1.66. 1.66 what? Well, what we were trying to figure out is what x equals. X equals 1.66. So it's 1.66 milliliters. That's what we were trying to figure out. So the answer is 1.66 milliliters is what should be prepared. The second part of the question asks you to answer or asks you to mark the amount to be administered on the syringe. This syringe is marked, you can see here. Here is 0.5 mils, here is 1 mil, here's 1.5 mils, and here's 2 mils. So what you would have to do in this situation is figure out what each little black line means. Well, it appears that each little black line means 0.1 mils. So if we have to give 1.66, and since we're dealing with morphine, you don't want to give more than is required, then you wouldn't round up, you just give 1.6, and we can draw a line here where 1.6 mils is. Here is 1.5 mils, right here where it says 1.5. So the next line below that 1.5, right there, would be 1.6 milliliters. So on a testing question or a testing piece of paper or on the NCLEX where they're going to have you indicate where you would draw the plunger back to, just make sure you're really specific at that 1.6 there. Let's look at another question that doesn't deal with liquids, but instead deals with tablets. I'm going to resize this and change it for us. All right, continuing on, let's work on question number 2. So again, let's read the question and see what it is we need to focus on, and then eliminate anything that we really don't need to pay attention to right now. So the question says, the client has an order for glyburide 1.25 milligrams before breakfast and dinner. Available are 2.5 milligram tablets. How many tablets should the nurse plan to administer? Well, the patient gets their glyburide before breakfast and then again before dinner. So this question is asking you to figure out how much you should plan to administer before breakfast, and then again how much should you administer before dinner. So basically they're asking you to figure out how many tablets you should give each time. Okay, so really, in order to figure out how many tablets I need to give before breakfast or how many I need to give before dinner, I don't need to know this stuff right here. I also really kind of don't need to know that. What I do need to know is that I need to give glyburide 1.25 milligrams. But what I have on hand, when it says available here, what they're saying is on hand you have glyburide 2.5 milligrams. So how many tablets should I administer? Well, following the process I showed you before, what you have on hand is 2.5 milligrams in one tablet. What do I need to give? What do I need to prepare? Okay, what to prepare? What I need to give is 1.25 milligrams, but I don't know how many tablets that is. So I've got my X here. Now, double check yourself. Sometimes errors happen because you've switched up the equation on one side or the other. Milligrams are in the first spot. Tablets are in the second spot. Okay? Then the next thing you want to do, remember, is to multiply the two outer components. 2.5 times x is 2.5x. Now multiply the inner components. 1 times 1.25 is 1.25. Isolate the x. 2.5, divide by 2.5 on both sides. This crosses itself out. 1.25 divided by 2.5 equals 0.5. So x equals 0.5. 0.5 what? Well, what was x? Just plug it in there. 0.5 tablets, or 1/2 of a tablet. How many tablets should the nurse plan to administer? 1/2 tablet in the morning at breakfast and 1/2 tablet in the evening with dinner. While we're on this page, let's go ahead and do number 3, and then you can do number 4 for yourself, and I'll be posting answer sheets. Okay, so number 3 says the client has an order for Ativan 0.5 milligrams. Okay, so I know I'm going to be dosing my patient in milligrams. And we need to give that IV every 6 hours PRN. Available is a vial containing 2 milligrams per mil. Good. This is still milligrams, so I don't have to do any conversions there. So we've got 2 milligrams per mil. Sorry, let me see if I can get rid of that line. Okay, hang on a minute. Sorry, I got interrupted there. So I think we were talking about what's ordered is in milligrams, and the vial comes with 2 milligrams per mil. And so now the next crucial piece in the conversation is what is the test question looking for? Well, it wants to know how many milliliters of solution should the nurse draw up or prepare for injection. All right, so what we're going to do again is over on the left-hand side, we're going to write down what we have on hand. So what we have on hand is 2 milligrams in 1 milliliter. And then on the right-hand side of the equation, we're going to write down what we need or what we need to prepare. And what we need to give is 0.5 milligrams, and we don't know how many milliliters that will be. So we're going to put X there for our unknown. All right? And then, remember, you want to multiply the outer components. So you'll multiply 2 times x, so you get 2x equals, and then you multiply the inner components. 1 times 0.5 equals 0.5. Now we need to isolate the x. So x equals whatever is the answer for 0.5 divided by 2, and the answer is 0.25. 0.25 what? Well, where was the x? It was over here by this milliliter. So the answer is 0.25 milliliters. You're going to prepare 0.25 milliliters, which means you're going to have to go and find a syringe that will measure something in that small of a volume. Now let's try a test question that's just a little bit more challenging. And read through this one. The provider orders Oronase 1.5 grams each morning. You have on hand Oronase 500 milligram tablets. How many tablets will you give? What you notice right away is that the doctor has ordered the medication in grams, but what you have on hand is milligrams. Grams do not equal milligrams, and so the first calculation that you're going to have to do is to convert grams into milligrams. So let's go ahead and do that. 1 gram is equal to 1,000 milligrams. You have 1.5 grams ordered, so how many milligrams is that? Using the same process that we used in our other test questions, multiply outer, and you get 1x equals, multiply inner, 1,500, because 1,000 times 1.5 is 1,500. Now you can divide by 1 to isolate the x, and your answer is 1,500. X equals 1,500. 1,500 what? 1,500 milligrams. So if it's helpful for you to keep things straight, what you can now do is go onto your test question and cross off 1.5 grams and write in 1,500 milligrams. Essentially what you've done is to make the question easier by making the units congruent, or they're the same. It makes it a lot easier to answer the question. All right, so now that we've converted grams into milligrams, now we can set up our test question. So what we have on hand is 500 milligrams in 1 tablet. And what the doctor has ordered is 1,500 milligrams. So how many tablets is that? Using our same system from before, multiply outer, and you get 500x. Multiply inner, and you get 1,500. because 1 times 1,500 is 1,500. Okay, now we need to isolate the x. So divide both sides by 500. Cross these off. X equals 3, because 1,500 divided by 500 is 3. 3 what? 3 tablets. Okay, so this will be the last problem that we'll work through together, and then I think I've given enough examples that you should be able to start working on those practice sheets and be successful with them. I chose this one because it requires 3 parts in order to get to the right answer. So let's just dig into this and see where we go. The provider has ordered digoxin 50 micrograms per kilogram. You have on hand digoxin 0.125 milligrams, and your client weighs 5 kilos. Well, as with the other problem that we just did, you notice that micrograms are not the same as milligrams, and it really is best to do that conversion first. Convert into the unit that you have on hand. It makes it easier to dose the patient that way. So what we need to do then is convert micrograms into milligrams, because milligrams is what we have on hand. So you're going to have some of these things memorized, but basically 1 microgram is equal to 0.001 milligrams. And what you have on, or what the doctor has ordered, is 50 micrograms. So how many milligrams is that? Using our mathematical computation, you're going to multiply outer, and you end up with 1x equals, and then multiply inner, and what you end up with is 0.05. Divide by 1. X equals 0.05 milligrams. So now we can go up here and cross this off. And I'm just going to rewrite it over here to make it easier. And feel free to do this on your test questions too. Just make it easy on yourself. So we converted that 50 micrograms into 0.05 milligrams per kilogram. All right. So now we know that the doctor has ordered 0.05 milligrams per kilogram. So the next thing that we need to do is figure out the dose based on the weight. We know that our patient weighs 5 kilos. So in order to figure out how much we should give for a patient who weighs 5 kilos, that's just basically simple multiplication. So if the doctor ordered 0.05 milligrams per kilogram and the patient weighs 5 kilograms, then you're going to multiply 5 times 0.05, and your answer will end up being 0.25 milligrams is the total dose that you'll give. So this 0.05 milligrams per kilogram now becomes an order that the doctor wants us to give digoxin 0.25 milligrams. And we figured that out because we multiplied their weight in kilograms by the dose that they need to get. That was step 2. Now, step 3. Through your other calculations, you figured out that what has been ordered is 0.25 milligrams, and what you have on hand is 0.125 milligrams in 0.5 mils. So now we have 0.125 milligrams in 0.5 mils. That's what we have on hand. And what we're supposed to give is 0.25 milligrams, but we don't know how many mils that is. Okay? Multiply outer, and you get 0.125x multiply inner, and what you get is 0.125. Interesting. So divide by the 0.125. Do that on the other side also. And your answer then is 1. X equals 1. 1 what? 1 milliliter. So we had to go through 3 steps in conversions. A couple different conversions and then this multiplication thing over here to figure out how many mils you will give. And the answer is 1 milliliter of the digoxin.